Welcome to Infection Tube. Today we're diving into aminoglycosides, a vital class of antibiotics that play a key role in treating serious bacterial infections. In this video, we'll walk you through the 10 must-know facts about aminoglycosides to help you easily understand why they're so important in healthcare. For a quick overview, aminoglycosides, like gentamicin, streptomycin, and paromomycin, are antibiotics that work by stopping bacteria from making essential proteins. They target gram-negative bacteria, some gram-positive bacteria, but are not effective against anaerobes. Since they don't absorb well when taken orally, they're usually given by injection and are cleared from the body by the kidneys. These antibiotics are commonly used in combination with others to treat severe infections like septicemia, hospital-acquired pneumonia, complicated UTIs, and intra-abdominal infections. Common side effects include nephrotoxicity, ototoxicity, and sometimes muscle weakness. If you're curious to dive deeper into the details of aminoglycosides, how they work, when they're used, and what makes them so unique, stick around for the rest of this video. Let's get started. First up, the names. Some people think any antibiotic ending with mycin or even sin is an aminoglycoside, but that's not true. For example, vancomycin, erythromycin, and azithromycin all end the same way but aren't aminoglycosides. Just knowing the actual members by heart is key. Here they are: gentamicin, tobramycin, amikacin, plazomycin, streptomycin, spectinomycin, neomycin, and paromomycin. Second, know the target bacteria. Aminoglycosides go after aerobic bacteria. That means they're great against a broad spectrum of aerobic gram-negative and gram-positive organisms, including mycobacteria. But they're not effective against anaerobes. Third is knowing the unique uses for specific diseases. The term special clinical applications refers to specific, less common or unique uses of aminoglycosides outside their usual role of treating infections caused by aerobic gram-negative bacteria. Aminoglycosides aren't the only drugs used for these infections, but they play an important role in situations where other drugs don't work due to resistance. The infection responds well to aminoglycosides. The patient can't use other antibiotics, due to allergies, for example. Examples of special clinical applications. Paromomycin works well for protozoa infections in the gut because it stays in the intestines without getting absorbed. Spectinomycin can treat gonorrhea in patients allergic to penicillin or cephalosporins. Streptomycin and amikacin help treat drug-resistant tuberculosis, TB. They are used as a backup if the first-line TB drugs don't work. For rare but dangerous diseases like plagues caused by Yersinia pestis and the tularemias caused by Francisella tularensis, these drugs are considered very effective. But other options like doxycycline can be used if needed. Fourth is how they work. Aminoglycosides target the bacterial ribosome, the protein-making machinery. It targets specifically the 30S ribosomal subunit. Think of them as jamming the gears inside the ribosome, causing it to misread instructions, which ultimately stops the bacteria from making essential proteins. The bacteria can't grow, and they die. Fifth, know that aminoglycosides are generally stable against resistance, meaning bacteria don't easily become resistant to them. However, some bacteria can produce enzymes that alter aminoglycosides, making them less effective. But the interesting part here is that not all aminoglycosides are affected by these enzymes in the same way. For instance, if a bacterium is resistant to one aminoglycoside, like gentamicin, another aminoglycoside, like amikacin, might still work. It depends on the type of enzyme and which aminoglycoside is being used. Sixth, remember that aminoglycosides are often used in combination with other antibiotics. This is especially common for serious infections like septicemia, hospital-acquired pneumonia, complicated UTIs, intra-abdominal infections, and osteomyelitis. Using aminoglycosides with other antibiotics improves the chance of covering any resistant pathogens. Seventh is about monotherapy. While aminoglycosides are rarely used alone, there are a few cases where they're the primary choice as we mentioned before. Tularemia and plague, streptomycin and gentamicin are first line. UTIs with multi-drug-resistant bacteria. When other options don't work, aminoglycosides can be a choice. Gonorrhea. Spectinomycin is an alternative for patients with severe penicillin allergy. Intestinal amoeba. Paromomycin is used orally here because it isn't absorbed from the gut. Eighth, let's talk about two unique properties. The first is post-antibiotic effect. This means aminoglycosides continue to suppress bacterial growth even after drug levels drop. Think of it like a slow release effect, where the bacteria are kept down even when the drug isn't actively in the bloodstream. In general, the duration of post-antibiotic effect is longer for gram-negative organisms than gram-positive organisms. The duration is reduced in the absence of polymorphonuclear leukocytes. And the second is concentration-dependent killing. The higher the dose, the faster and more complete the bacterial kill. This is why they're given in strong doses up front. Peak serum aminoglycoside concentrations are observed approximately 30 to 60 minutes after termination of an intravenous infusion, or 30 to 90 minutes after an intramuscular injection. Ninth is how they're given. Aminoglycosides are not absorbed through the gut, so they're mostly given IV or IM. The exception is paromomycin, which is taken orally for gut infections because it's not absorbed. Finally, elimination and toxicity. Aminoglycosides are removed almost entirely through the kidneys. That's why they can be hard on the kidneys, so known as nephrotoxic drugs. They're also known for ototoxicity and, rarely, neuromuscular blockade and muscle weakness. Thanks for tuning into Infection Tube. We hope these 10 key facts about aminoglycosides helped you understand this powerful antibiotic group a little better. If you found this video useful, don't forget to hit the like button and subscribe for more infectious disease insights. And we'd love to hear from you. Drop a comment below with your questions or thoughts. See you next time.